Hi, my name's Kurt. I'm the founder of QuestBound. This is going to be an in-depth look at QuestBound's logic editor. When you create a rule set in QuestBound, you can think of it as creating two different layers. The first is the presentation. This is the rulebook and the character sheet templates that you'll deliver to your players so they have everything they need to play your game. But the second layer underneath that is the engine that makes your rule set dynamic. This controls things like character sheet automation, or the automatic creation of rulebook pages. That engine layer in QuestBound is controlled through logic, which is what I'm going to demonstrate today. I'm going to start by creating a new rule set. And then we're going to click over to Attributes. Logic is written and controlled through attributes in QuestBound. And I usually describe attributes as the atomic particles of your rule set. These are the most basic pieces of information that control everything in your game. They are descriptors for entities like characters and creatures and items. Any word you use to describe these things could probably be an attribute. If we're talking about characters, that might be a character's age or height or level or class. Really anything that influences game mechanics. I'm going to create an attribute called age, and then in this type dropdown you'll see there are 4 different options. I'm going to talk about the first 3 and then we'll come back to the last one later. The first 3 are what we'll call primitive attributes, and these are just the type of information that the attribute is holding, the type of value. Number can be any number, positive or negative, both integer and floating point decimals. Text is any word or group of words. And Boolean is any value that can be represented as either yes or no. Meaning if you can ask a question about your attribute and the answer is either yes or no, that's a Boolean. Is my character dead? Is my character ancient? Anything like that. But age is probably represented by a number. Category is just a way to organize the chart of attributes. We're going to leave that blank. And then default value is the initial value that your entity will have. And we're just going to leave that at 0. So I'll create that, and then it'll appear here in the attribute chart. Now when you create an attribute in your rule set, it is a global attribute, meaning everything in your rule set will get its own copy of that attribute. Every character created will have its own age. Every archetype could have its own age. Item, when we get into world building, any region will also have that copy. So you don't need to necessarily distinguish within your attribute creation, whether it belongs to a character or whether it belongs to an item. Everything will have awareness, and then depending on how you use that attribute, it will influence, what entities are affected by it. So now that we have this attribute, let's talk about that presentation layer for a second. I'm going to go into Sheet Templates and just create a new one. Sheet templates are how your players will control their characters from your rule set. And as you design the template, you're going to place fields that can be used to control attributes. So if I drag out an input, and I go up here to attribute assignment, age now appears in this list because we just created it. If I select it, and then I go into preview mode, I now have a way of controlling this character's age. Right, this is a sheet template. Every character created from your rule set could have a copy of this template as their character sheet. And that sheet will have this field, which controls this character's age because we just assigned it. So I can move this up and down. And by changing this input value, I am changing this character's age. Controlling an attribute like this through a sheet input is what we call a controlled attribute. And it's exactly what we're doing. We're giving our players control over this character's age. lots of your attributes will be controlled, maybe even most of them. These are things like age and name, or height, really basic descriptors that aren't necessarily dependent on game mechanics, but they're just describing a character or describing an entity in some way. And if you expect your player to have total control over that, then that will be a controlled attribute. And to make a controlled attribute, you do exactly what I just did. You make a new attribute, you give it a type, and then you expose some method of controlling it in the character sheet template. And then that's it. From then on, the player has control over that. But the other type of attribute that we want to talk about are derived attributes. And those are descriptors that do depend on some game mechanic to calculate their own value. So let's make, as an example, I'm going to make a new attribute called vitality. And then I'm going to make one more called hit points. And let's say in our game, which I am, just making up as we go along here, let's say there is a mechanic where a character's hit points is derived from their vitality score. And maybe it's as simple as a character has 10 times the amount of hit points as is their vitality. So in that way, we don't really ever expect players to control hit points. We want to do that calculation for them. And to do that, we're going to add some logic to the hit points attribute. So over here on the right, under the controls column, the very first option is logic. So we'll click that to open the logic editor. So the logic editor works as a way of visual programming. You will also see this called a node-based editor sometimes. And it's a way to visually create instruction sets, which are executed in the same way that software programs are. But instead of writing code through text with special syntax and languages, we're going to create those programs by placing nodes visually and then drawing lines to connect them to build a sort of flowing set of logic. So to add a node, we want to open the context menu. You can do that by right-clicking, and then you can click away to close it. You can also do that by pressing Shift and Enter together, and it will open the menu. The context menu has a list of all of the different node types broken down by category. So we can scroll down through this list and see them all. We can also filter. And then if we hover over any of the options, we'll get a brief description of what those nodes do. The first type of node I want to talk about are primitives. So just like with attributes, we have these three options of primitive values that we can use within our logic. Number simply supplies a number as its output. Text, same thing, but with a word or collection of words. And then Boolean supplies a true or false value that we can control through this checkbox. So at any time, we can come up here to the top left and click this light bulb icon, and that will display the value of the node hovered over its top left corner. Now for primitive values, this is a little bit redundant, but as we start connecting nodes together through their inputs and outputs, you'll see that this is actually quite handy, so I'm going to leave this toggled on for most of the time. So if primitive nodes just supply their values, there's not much we can do with them just by themselves, right? Logic is about combining nodes through operations so that we can do some kind of calculation on them and then supply a result. Right, so one thing we might want to do is add two numbers together. I'm going to get rid of this Boolean in text. We're going to stick with this number, and then I'm going to duplicate it so we have two numbers. We'll set this to 3 and set this one to 2. So if I want to add these two numbers together, I'm going to add another node. And under here under math, we have an add node, sums two or more numbers. You'll notice that the primitive nodes have this icon on the right, while the add node has both one on the left and one on the right. So every node has some type of input and output, or some type of I/O. And those are going to be the controls for how you connect these nodes together. Primitives only have an output, and that's because primitives don't have any inherent or internal operation. Their whole point is to just supply their value. So they'll supply that value through their output. While other nodes, which take an input, have some kind of internal calculation that they're going to do. And the way that they get those values so they can operate against them is through their input. So if I want to supply the number 2 to this add node, I'm going to click on its output and drag over to the input of the add. And the input turned green, which just means that it is an allowed input type. It also, I don't know if you can tell, it's sort of like magnetically connected to it. And when it does that, if I release, it will create this connection. And so now these two nodes are connected. If I move either one of them, that connection is going to stay. You'll also notice that the add node now has a value hovered over its top left of 2. If we think about what the add node is doing, it's going to take all of its inputs, it's going to sum them together, and it's going to take that as its value. So since the number 2 is the only thing connected to its input, it's just summing 2, which is the value 2. So now this add node has a value of 2. If I connect 3 to the same input, it now has 2 inputs. It's going to sum them together and give us 5. Now that this add carries the value of 5, I can supply that value through its output. Say I wanted to add this again to some other numbers. If I take this and connect the output of the first add node to the input of the second, it will pass its value, and now the second add node is summing 5 to nothing, and it gets 5. We can add another number to make this clearer, say 10. We'll add this to 10, and then we get 15. So this is the way that logic flows in QuestBound. We're going to connect the outputs of some nodes to the input of some kind of operation. It's going to run that operation and derive its own value and then pass that value on through its output. And we'll build more complicated like statements or more like logic connections this way. And then ultimately we'll do something with that final result. But let's talk about operations a bit more before we do that. In the math category, we have several different things we can do, mostly with numbers, right? All 4 basic math operations are supported. That's add, subtract, multiply, and divide. And then we can also round a number, either using the mathematical round, which takes the closest, or rounding up or down to the next closest integer. And we can bring out these nodes in the same way that we did the add node by selecting it from the context menu. But we can also select an existing node by clicking its center icon and then changing its type here once it's been placed. So we can change this to a multiplication or a division. Let's switch this back to multiplication. And then put this at 1, and then I'm going to put this at 10. So of course the result of our multiplication is 10. But what do we do with this result? As of right now, it's being executed, right? These operations are running, and each node is holding its own value, but those values aren't really going anywhere. When it comes time to sort of set our final result on this logic, we need to use a special node called return. So we're in logic of hit points. I said before, hit points is going to be derived from vitality. For right now, let's just say that hit points is the final result of this logic that we have in place right now. So hit points will be 10. I'm going to add a return node and place that here. And what return does is sort of ejects a value outside of the current logic that we're in. Right? So in the case of a derived attribute, return is going to set its value to the value of this attribute. And I'll draw your attention up here to the top right. We have this label, derived value, and it's blank. Because right now, this attribute isn't deriving its own value. It's running a calculation, it's ending up with 10, but then we're not setting that anywhere. If I connect the output of this multiplication node to the input of return, return gets a value of 10, and then up here we see the derived value of the attribute is 10. So return is taking its value and it's applying it to the attribute itself. We're going to go back to our sheet template, and I want to add a text node. Like inputs, text nodes can also be assigned an attribute. I'm going to assign it hit points, and text will just provide a read-only version of that attribute. So players can't control it, but they will be able to see what the value of the attribute is. Make this a little bit bigger. So we get the value of 10 because our logic of hit points is deriving the value of 10, which is what we want, right? This is a derived attribute now. Well, the attribute of age is still controlled, and the players can control it. 10 is the value of hit points always, because we're setting that in its logic. And even though the default value of hit points is 0, it doesn't matter because we're deriving its value here in its logic. So it's going to be set to 10, and it will always be 10 because this is just a static calculation, which is not very useful, really. Because if we wanted hit points to always be 10, we would just set its default value to 10, and then we would never expose any way to control it. What we actually want is hit points to be 10 times a character's vitality. So we need some way to read the vitality score within this logic. And we can do that with an attribute node. So when I open the context menu, I see attribute as an option, but I can also just directly add attributes from the menu. So I can either add an attribute node and then select vitality from this dropdown, or I can search for vitality and then select it directly from here. Either way works. If you already know the attribute that you want to read, you can just search and apply it directly. So the attribute node gives us a way to pull in the value of other attributes outside this logic. If I turn on our node value mode, right now this has a value of 0 because the default value of vitality is 0. But I also have a field where I can adjust this value, and it will only affect this logic. Right? This is a way to test and say, if the value of vitality were some other number, how would that affect my logic? And so I can change the number here, and it will change the displayed results here at the top left. So we said before that attributes are just primitives, and if that's the case, we should be able to just swap any primitive node with an attribute node of the same type. Since vitality is a number, I should be able to just use vitality as an attribute node in place of this number 1. I'm going to delete this number 1 and bring this vitality attribute down, set this to 1, and then connect it to our multiplication node. So now I have a way of controlling this, and we can run our derivation for hit points, which should be vitality times 10. And I can say if a character's vitality is 4, its hit points should be 40, which is what I expect. And that's what we're seeing in the return node and the derived value on top. But this is just a way of, in this test value, just testing. Really, we're injecting the character's vitality in this logic. And since we're doing that, we're saying that every time a character's vitality changes, I want to recalculate the value of hit points and then set the value of hit points to the result of that calculation. So by adding an attribute node and setting it to vitality, we're setting a dependency to vitality. Right? Hit points now depends on the score of vitality. And because of that, every time vitality changes, hit points could potentially change. It'll rerun its calculation and it will set its own value. Back to our character sheet. Here we have hit points. We'll set a label for this. And actually I'll show you one other way that we can read the value of hit points. I can remove this to make it just a simple text again. And then if I set the value of text to say hit points or HP, and then I'll surround the name of the attribute I want to read with these curly brackets, and that will inject the value of that attribute directly into the text. This is called text replacement. You can do it with any attribute. You can do it in text components or in content components, and it will just replace that value with the attribute's value. I'm going to switch this from age to vitality. And so vitality is 0. 0 times 10 is 0, so this is correct. What we should see is every time we change vitality, the HP changing to that number times 10. Change this to 1, we get 10, 2, 20, and so on. You can see now this is the way that you build automation into your character sheets. By creating logic within hit points that depends on vitality, and then exposing a way to control vitality in character sheets, what we have is an automatic derived value for hit points that changes every time vitality changes. All right, back to our attributes. This alone is enough to build all sorts of mechanics. And it's very common in RPGs that the value of some attribute will be just a simple calculation based on some other one that will involve dividing a number or rounding it or adding two numbers together or something like that. And if that's the case, primitives, attributes, these math operations, and then just returning that will be enough to implement that mechanic in your rule set. One common thing that you might want to do is to clamp the result between some minimum and maximum value. Say that in our game, hit points can never go above 50. Regardless of your vitality, maybe your vitality can continue to grow and inform some other mechanic, but your hit points caps at 50. And maybe vitality can even dip below 0, but your hit points should never dip below 10, say. So we have a couple of options of doing this. To set a minimum and maximum, we could inject some logic in between the results of this multiplication and the return node that says, if it's less than 10, set it to 10. If it's greater than 50, set it to 50. Otherwise, set it to its value, which is, that'll work, but it's kind of a lot. Well, an easier way to do it that's built into QuestBound is to use the default value node. Default value, you can see, doesn't take an input. This will always just supply the default value of the attribute, which in this case I think is 0. But there's also these two options to set a minimum and maximum, and that will control the min and max value of the attribute itself. So if we can set the default value here. If we say set it to 3 and then go back to attributes, the default value of hit points is now 3. Doesn't matter in our use case because we're deriving it, but this is a way to control the default value. But if we want to set a min of 10 and a max of 50, we can use these number nodes and then just connect them here to these inputs on the default value. So now we have a minimum and maximum set. If I go here to test and I raise vitality to 7, the result of the multiplication is 70, but the result of our attribute value is 50. And that's because we're setting this 50 number. If we set this to 51, it would go to 51 because it's going to take the max all the way up into 70, and then it'll take 70. So this is just an easy way to control that. Anytime you need to set a minimum and maximum value on an attribute, even if there's no other logic, you can do it like this. Say that we wanted to, as an example of a controlled attribute, right? Age is controlled, it's meant to be controlled by the player, but say that we don't want them to be able to add negative ages. We can set a minimum of 0. And then back in our character sheet, I'll re-add the age input. And then I'm going to try to lower it. So I'm pressing the down arrow to lower that to -1. And it won't go below 0. If I delete this and say -50, it just resets it to 0. This attribute is still controlled. We're just setting like left and right parameters on it through minimum and maximums. Let's make a new attribute. We're going to build off of our health system that we've sort of started creating here. And I'm going to make one called dead. And this will be a Boolean value that just tells us if the character is dead or not. Remember that Booleans are attributes that can be answered with a yes or no question. Is my character dead? It's always yes or no, meaning it's always true or false, which makes it a Boolean. And we're going to default it to false because characters don't start out as being dead. I'm going to open the logic of dead, and what I want to do is say a character is dead if their hit points are less than or equal to 0. This is a way of deriving Boolean attributes, right? Because when we're deriving hit points, it's the result of some math, because hit points is a number. But since dead is a Boolean, how do we derive a Boolean? How do we derive a true or false value? We do that through comparisons. Open up the context menu and search for comparative, and I get a list of comparative nodes. Comparative nodes will always return a Boolean value. Let's open up this one that says equal, checks if A is equal to B, returns a Boolean. So this node takes two inputs, A and B. If A is equal to B, it will return true, otherwise it returns false. The fact that comparative nodes always return a Boolean is sort of intuitive if we think about it, right? Because we're asking ourselves a question, is A equal to B? It's a yes or no question, so it will always return some Boolean value. And we can use the value to derive a Boolean attribute. So we want to know, well, first let's just test this with two numbers. Is 2 equal to 2. Turn on this mode. We'll connect the first number to A and the second number to B, and then the value of this node turns to true because 2 is equal to 2. If I set this one to 3, 3 is not equal to false, so it returns false. Just like with our hit points node, we can connect the output of this to a return statement. And this will set the derived value of dead to false in this case, true if they're equal. Right? Whatever the result of this comparison is, it will set that to the derived value of this attribute. But what we want to know is if a character's hit points is less than or equal to 0. So I can either bring out a less than or equal to node, or I can click this center icon and then change this to less than or equal. And I'm going to replace this top node with an attribute for hit points. And then I'll bring that out and connect this here. And then we'll drop this down to 0. Notice that hit points is now 3. That's because we changed the default value of hit points to 3 in our previous example. But if we set this to like 10 here in this test value, this will just give us a way to test it out within this logic. So is 10 less than or equal to 0? No. It's false, so we're going to set dead to false. But as we lower hit points to a negative value or to a 0 value, this flips to true, and then we set the dead value to true. Let's test this out in our character sheet. You can probably notice my workflow when I'm building out attribute logic is to create an attribute, set its logic, and then go to a character sheet template to sort of test out how these attributes are working together. So I'm going to drag out a checkbox node, checkbox component. Checkboxes can be assigned Boolean attributes. So we're going to assign it to dead. And it provides the character a way of controlling controlled Boolean attributes. Even though dead's not controlled, we're deriving its value. I'm going to put it here because it will be checked when dead is true, and then it will be unchecked when it's false. If I go into preview, HP is 0, which means the character is dead, so this is checked. If I move this up to 1, which makes HP 10, the character is no longer dead. This actually demonstrates something important that QuestBound is doing. The player, us in this case, we're controlling vitality only. But hit points has a dependency on vitality, so it recalculates when vitality changes. And dead has a dependency on hit points, so it recalculates when hit points changes. So by only changing one attribute, we set off a cascading series of events that will recalculate every value in that dependency tree. So you don't need to worry about necessarily saying that dead ultimately depends on vitality, which it does. QuestBound just figures that out, and it will recalculate dead every time it needs to. Okay, so we now have a way of showing if a character is dead, but a checkbox is not the most appropriate way to do that. Right? Dead is not a controlled attribute, so we don't want to expose a way to control it. We want to display it. A couple of ways we can do that. One, if we were to just assign the dead attribute to a piece of text, it will say true or false depending on if the dead attribute is true or false. So maybe that works for your game. You can also do text replacement, like what we were doing before, or we say dead, and then we put that in brackets, and it will say true or false, like that. But more than likely, for something like this, you're going to want to change some aspect of your character sheet entirely, depending on if the character is dead or not. I'm going to drag out an image, and we'll just set this to be something. 1 second while I find it. We'll do this one. Let's say this is my character portrait. So I'll put that here, and then I want to drag out a shape that is roughly the same size. And I'm going to make it a little bit transparent. Right? This is giving us like a transparent overlay. And then some big text that says dead. And I'm going to center that this way and make it bigger. Okay, so when my character is dead, I want this dead overlay. And just for fun, I'm just going to change this to be like a skull emoji. Just for fun. Okay, this is how I want my character sheet to change when my character is dead. So for Boolean attributes, any component in a character sheet can be conditionally rendered only if that attribute is true or false. So I've got this overlay selected. I go up here to Conditional Display, and then I set that to the dead attribute. I'm going to do the same for the skull. These two things will render now only when dead is true. So as I raise my HP above 0, we get this nice character portrait. If I raise it down to 0 or below, we now get this overlay that shows my character's dead. That's a bit of an aside. It's more about, the presentation layer of your rule set, but that is a way to use logic to change some aspect of your character sheet entirely. Back to attributes. Let's go back into dead here. So we can derive Boolean values through comparative nodes. There are cases where we want to compare Booleans together instead of numbers. Right now we're still comparing numbers to derive a Boolean. How can we compare Booleans to derive a Boolean? Back to attributes, let's create a new one called immortal. Is my character immortal? Yes or no? That makes it a Boolean. We'll default it to false. And then go back into dead. And I basically want to say a character is dead if their hit points are less than or equal to 0, unless a character is immortal, in which case they can never be dead. So I need some way of comparing the immortal Boolean with the derived value of this comparison node. I'm going to drag out immortal, which gives us a way to read it. And then I'm going to disconnect this return value and bring it up here. A character is dead if a character is not immortal and their hit points are less than or equal to 0. We can compare Booleans directly using logical operators. And the one that we actually want right now is this AND operation. Compares two or more Boolean values using the logical AND. And the logical AND states that it is true if all of its connections are true. But if any single one of them is false, the result of the AND operation is false. So I'm going to drag out to connect immortal, and then I'm going to connect the result of this comparison, which remember is a Boolean. And so now I'm going to just move these out of the way so we can focus on these two things right here. We're comparing these two. If they're both true, the result of and will be true. If either one is false, this will be false. I'm going to set the test value of immortal to be true. So this is true, the comparison is true, and is true. If this is false, or if one of these is false, then the result of and is false. So we're combining, or like joining multiple Booleans into a single Boolean, which we can then use to return the value. And then dead can derive its value this way. So this works, but the logic isn't quite right for our use case. We want dead to be true if immortal is false, and this comparison is true. So we can do two things. Basically, we need to flip the immortal value. We want to take the opposite of what immortal actually is and feed it into this AND operation to derive our final result. We can do that in two ways. One, we can use a different logical operator called not. And not just flips the value of its input. So we can disconnect this. We'll bring this out here. When immortal is true, this not will be false. When immortal is false, this will be true. And then we can feed that into true. Or sorry, feed that into and. And this will give us our final result. Hit points is less than or equal to 0. And the character is not immortal, meaning the character is dead. Which this is, the final result is true. If the character is immortal, the character can't be dead, so this is false. So this works. This is great. You can leave this as is. One just sort of quality of life thing that QuestBound offers is it has a built-in not operation within attribute nodes. So we can delete this, reconnect it directly, and then just toggle this not, and it'll work the same way. So up to you. It's just a shorthand that's built in. So now then, back to our character sheet. We do want to control whether a character is immortal. It's a controlled attribute, so we'll assign it to a checkbox. HP is 0, the character is dead, unless this character is immortal, in which case they are alive and well. Doesn't matter what our vitality is. As long as we're immortal, we're good. As soon as we are not immortal, if our HP is 0 or lower, we're dead. If it's higher, we're alive. Combining Booleans this way, or comparing them, is going to be crucial in quite a lot of logic. Anytime you want to derive the results from multiple Booleans or multiple Boolean attributes, you're going to either use an AND or an OR node, or you're going to have some condition, which we'll talk about in a second. For OR nodes, they work in a similar way. You can connect multiple Booleans to them. But if any single one of the connections is true, the value of OR will be true. So let's think of an example here. Let's say that we want to prevent a character's death if they're either immortal or if they are blessed. So blessed would be a new attribute. We don't have a blessed attribute yet, so we can go back to the attribute view and create it. Or what we can do is set a Boolean here and bring it up. And then primitive nodes have this option to promote to attribute. So I'm going to do that, and then directly from this view, I can create a new blessed attribute. And then it will create it here. Just easier ways, you don't have to bounce back and forth. So if, let's turn off this not. If a character is blessed or immortal, then we want to prevent them from being dead. which means we need to take the opposite of what we pull out from this right here. Is that right? Let's think about this. A character is blessed. This is true, which means we need to flip that into our AND comparison and say that they're not dead, even though their hit points are 0. Character is not blessed. Their hit points are 0. They're dead. Character is immortal. They're not dead. So if either one of these are true, then a character can't be dead. But as soon as they're both false, we go back to falling onto the hit points value. We can use this not node here. We can also just flip these on both. It's up to you. Since we're using multiple Boolean attributes here, I think it's a little bit cleaner to just take a not. But either way. Back to our character sheet to test our new mechanic. I'm going to copy and paste this checkbox and change the immortal attribute to blessed. I should probably start labeling these because it's confusing. Let's go immortal. Copy that. Blessed. This is a pretty ugly sheet. We might do a little bit of styling at the end of this video. Okay. Does everything work? Vitality controls HP. HP controls death. Immortal or blessed will prevent death. Looks like it works. So now that it does, let's make our health system a little bit more complicated. Back to attributes. Okay. So let's introduce a poison mechanic. Poisoned, which will be a Boolean. And then what I'm going to do is change hit points to be max hit points. And then I'll create a different attribute called hit points. And the reason I didn't create max hit points is because I want the logic of what is now max hit points to stay the same. So max hit points is derived from vitality, but then hit points is going to be the number that sort of influences everything else. So we'll have to go into dead and change this to hit points. Yeah, so nothing's really has changed, except now we need a way to derive hit points from max hit points. So open up the logic of hit points. I'm going to say that hit points is the value of max hit points unless a character is poisoned, in which case it is half of its max hit points. So I'm going to start by pulling out the attributes that I know I'm going to need. That's max hit points, and that's poisoned. Okay. And so this is the first time where we are potentially setting the derived value of this attribute to one of two possibilities. Either it will be max hit points, or it will be max hit points divided by 2. So the first thing I'm going to do is ignore poison for a second, and I'm going to pull out a divide operation and a number so we can get our first value, right? 1.5. Let's say that max hit points right now is 50. And then I'm going to just pretend that we're returning that directly. So in one scenario, this will be the result. In another scenario, which means that we're going to pull out a different return node, the result will be just max hit points. Notice that the attribute node can supply its value to as many nodes as it needs to. You can connect as many outputs as needed. It'll just continue to supply that value. So we'll connect this one directly to return, which in our first scenario will be just that value, 50. In our second scenario, it will be 25. So we need a way of controlling which one of these scenarios actually supplies the derived value. The first way I'm going to show you how to do this is through a condition, also called an if node. If is a way of branching logic into one of two distinct possibilities, which is exactly what we want to do here. Either the result of this will be max hit points, or it will be max hit points divided by 2. And whether or not, or like which branch is active is dependent on a condition, which is a Boolean value, right? Conditions are always Booleans. They can be the result of some comparison, or they can be a Boolean directly. In this case, that condition is whether a character is poisoned. So I'm going to drag out the output of poisoned into the conditional input of if, and that will control now whether this branch is true or branch is false. If a character is not poisoned, meaning this is false, we want to return this max hit points. So bring this up, try to make this as easy to read as possible. First scenario is off of this false branch. So return has this special input called an execute input. It's like this double arrow right here. When nothing is connected to an execute input, the node will operate as usual, right? It'll just execute and it will derive its value, and that'll be it. If something is connected to it, then it will only execute if the value of that connected node is true. Anything else, it will ignore the node entirely. So if a character is not poisoned, we're going to drag out this false branch into the execute node of the return, meaning this node will only return if a character is not poisoned. If a character is poisoned, the value of this node disappears because it's not even being calculated. This is now on an inactive branch, meaning everything connected to it is going to be ignored. And now our derived value up here is 25 because the node that is still active has a value of 25. So this is actually enough to make the whole thing work. If we wanted to be more explicit, we can connect this true branch to the execute node of this return value. And now exactly one of these will be active at all times, depending on if poison is true or false. Why does it work if there is no active branch? Because there is no execute operation connected here, therefore it will execute. Therefore, QuestBound will look for the first return node that has a value, and it will return that value, which is 25. If this were not connected, the result would always be 50 because the first return node is 50. I don't know if we talked about ordering operations or not, but here's a good example. How does QuestBound know this is the first return node? It's because it's placed at a higher vertical placement. So if I bring this down below, then the first node becomes this one and the value is 25. Quick aside, if we wanted to do something like subtract two numbers, duplicate that. If I want to subtract 2 from 0, right, 0 minus 2, we'll get negative 2. If I bring this up above, we get 2 minus 0, which is 2. QuestBound will always order nodes dependent on their vertical placement. It doesn't always matter. Like if you're going to add two numbers, it doesn't matter which one comes first. But sometimes it does. So when it does, make sure that you're placing nodes in their correct order. In the case of return nodes, the first one that has a value will be used to set the derived value. So we basically need to make one of these nodes inactive. We do that by branching it. We can branch both of them, and that works. One of them will always be inactive, but we only need to branch one to make this node inactive when it's appropriate. You may also notice that conditions have inputs. Drag over here just for a quick example. Okay. So you can say start with a number and then pass that into the input of the condition. And then we'll control that just with this Boolean. And then depending on the branch, it will pass that value either to the true or false branch, depending on the condition. So we'll bring two different add nodes out and then two different numbers. We'll say this is 1 and this is -1. So you're starting with 10 and then branching. Right now the condition is false, so it's branching to the false branch, and then it's passing 10 to this add node, which is then adding -1, making it 9. This node up here is still 1 because it isn't being passed anything from the if node because it's on an inactive branch. But the rest of the logic is still running. It's still adding 1 to nothing. If we flip this, it does the opposite. 10 now gets passed to the true branch, and that makes this node 11. So you can have any number of nodes to the left of the if branch feeding into its input, and then it will pass the result of that to the active branch depending on its condition. I'm going to get rid of this. We'll come back to conditions. At the end of the video, I'm going to give a couple of examples, and we'll be able to dig into conditions a little more. But for now, we're going to move on and talk about charts. So charts in QuestBound are CSV files. They're like spreadsheets. We're going to make one real quick. Let's see what we have. Let's make this modifier chart. Call it modifiers. And then we'll take a look at it. So this is a table. This is from D&D, which just matches an ability score to its modifier. So just two columns, right? Two numbers. We can read from this chart within attribute logic to perform a lookup, and then pass it some logic to filter which row of the chart we want to read from. So let's make a new attribute. Let's make two, and we're going to borrow this from D&D. We'll call it strength and strength modifier. And then strength modifier is what we're going to edit. So what we want to do is look up the modifier value of the chart we just made dependent on the character's strength score. So first I'm going to bring out strength. And then I'm going to bring out this chart. So we can either bring out the chart node directly, or we can just search for the chart we just made. I'll bring out the node and then just select modifiers. And then we have these two drop downs, right? Select from is the column of the chart where we want to ultimately pull this value, and that's modifier, because we're looking for the modifier. And then here, where value n is the column that we want to filter on. So this is the value that we're going to be passing in this comparison to find the row that we're interested in seeing. So from modifier chart, select from the modifier column where the value in score is equal to this character's strength score. So I'm going to bring out an equal to comparison node. And then if I turn this mode on, if I connect the comparison output of the chart to this, and then I connect the strength attribute to this comparison node, I'm now going to filter each row of the chart based on this strength value. So if I set this to 10, the value of the chart becomes 0. So it's using 10 as a key for the score column, and then it's pulling the value from the modifier column that matches in that row. So I move this up to 12, we get 1, and then for every 2 we should go up 1 because that's the value of the chart. We'll go back and look at the chart real quick. So starting at 10, we get 0, and then for every 2 we go up from there. So this is just a way to pull a key value pair out of an uploaded spreadsheet, right? Because it's not always possible, depending on your game mechanic, to use math or to use just pure logic to find values. Sometimes you're just performing a lookup on a table. And so the chart node is how you're going to do that. This could be any comparison. We could change this to less than. And now it's going to find the first row where the value and score is less than 16, which is going to be the very first row of the chart, which makes this -5. If we wanted to start from the bottom of the chart and look up, as opposed to the top, which is what it does by default, we can click on this option here. This is reverse order of chart rows. And then it will just flip the chart and then perform the exact same filter and function. Again, I'm going to come back and give some examples at the end of this video, which will have more with charts. But for now, we're going to move on and talk about something else. I'm going to go back to our poisoned attribute. So remember, poisoned is controlled. If we look at our sheet template, we don't have a, let's bring out a checkbox for this. Set this to poisoned. Set a label real quick. And poison brings health down. Let's look at our hit points. Right, so poison brings hit points to half of our max hit points. And that's in the logic of the hit points attribute. But there's another way that we can use poisoned to influence other attributes. And we're going to do that within the logic of poison. I'm going to make one called stamina. It's a new number attribute. And then let's set that to a default of 100. And so similar to hit points, every time a character is poisoned, I want to drop their stamina by 10. So we could do that in the logic of stamina, where stamina is deriving its value and it depends on poisoned. But the other way we can do it is in the logic of poisoned through something called a side effect. Side effects provide ways to alter other attributes other than the one of the logic that they're in. And in this case, we want to alter stamina. So poisoned is still a controlled attribute. We're not going to derive the value of poisoned here. Instead, we're going to say every time poison changes, trigger this side effect. And the side effect will say reduce stamina by 10. So we're going to need to read stamina, and we need to subtract it by 10. By the way, one other way that you can make primitive nodes is just to type in the value that you're looking for and then hit enter, and it'll automatically create the type of node. Stamina minus 10, and then assign that value to stamina, the stamina side effect. So the side effect is going to say, whatever it takes as an input, assign that value to the stamina attribute, and it's going to permanently alter it. So every time poison changes, right now, we're going to reduce the value of stamina by 10. We can test this real quick in our sheet template and bring out just a text node, assign that to stamina. Right now it's 100 because that's the default. And then if we click poisoned, it brings it down to 90. But if we check poisoned again to turn poisoned off, it's going to bring it down to 80. That's because we're saying every time poison changes, reduce stamina by 10. So we want to add some kind of condition in there that says only if poison is true. That way the character can recover without losing more hit point, losing more stamina. So back to poisoned. Two ways we can do this. We can use a condition that says if poisoned, and then from this true branch, we can use a different node we haven't talked about called set. We're going to disconnect this. I'm going to feed the value of the subtraction into set. And then I'm going to branch from this if node's true branch into the execute value of set. We talked about executes on return nodes. Essentially, since there is a connection here, if it's not true, then it won't do anything. We can supply the output of set into the input of this side effect. So since poison is not true here, nothing is happening. If poison is true, then we get this reduction and it sets it to 90. Let's make sure that works first. Poison, go down to 90. When I toggle it off, it stays at 90. When I toggle it back on, it goes to 80. And we'll keep doing that. Yep. And since side effects permanently alter attributes, stamina will now stay at 70 forever because we don't have any other way to bring it back. If we expose some control for stamina to the player, they can raise it manually, or we can add logic to bring that value back up. So this works. In this case, we can actually simplify this because side effects also have an execute input. So we can get rid of set and we can get rid of this condition and just attach this directly like that. And this should work the exact same way. Anytime you see this double arrow execute input, it's going to operate in a similar way, right? You could probably attach it directly to a Boolean, or you can attach it to some conditional branch, just depending on what your mechanic is. Okay, last thing we're going to talk about before going into some examples is the final type of attribute. Remember at the beginning, I said there were 3 primitive attributes and there's a 4th type we talk about. This 4th type is called an action. And unlike primitive attributes, actions do not hold values, and they must be manually triggered by players. So I'm going to make one called poison. Not poisoned, which we made before, which is a Boolean attribute, but poison, the action of poisoning something. And then we will go into its logic. So actions, since they don't derive their own values because they don't have values, they're mostly used to hold side effects. And they're going to hold side effects that can only be manually triggered by players. And in this case, let's say really what I want to do is just flip a character's poisoned attribute to true. If we go into side effects and we'll bring up poisoned, so when this action is triggered, we're going to set poisoned to be true. And that's it, right? Very simple. We'll go into our sheet template now. And actions are sort of like controlled attributes in that you need to expose some way to trigger them to the player, meaning you need something in the character sheet that can trigger them. And an action can be triggered by several different types of components. We can bring out just text. And then there is, right next to the attribute assignment, there is an action assignment drop-down where we can select all of our actions. And this turns this text into a clickable button in the character sheet. And when you click it, the logic of that action will be evaluated. It'll be run. In this case, it just flipped poison to true. And we can toggle this off manually and then click this again, and it'll click it again. And every time we click it, it will run the logic, but since poison is already true, it's not going to do anything. So pretty much any static element in a character sheet can be assigned an action and become a button. We can drag out a shape and do the same thing, assign it to the poison action. And then that shape becomes clickable and it will execute that action. We can also use images as well. So you can make custom buttons for your character sheet that trigger actions that then affect other attributes of the character. There is another use case of actions, and that is to capture logic that you want to repeat across multiple attributes. So in the case of comparing logic to programming, you can use actions as reusable functions. We said earlier in the video when I was talking about setting minimums and maximums that we could either do it in the default node or we can do it in logic itself. Let's do it in logic, and let's choose the logic of strength. And then I will show you how to do that as a reusable action. Actually, let's go ahead and make this action called clamp. It'll be an action, and it'll just clamp its input value between some minimum and maximum value. So in order to do this, this is logic that will only ever be used in other attributes. So we need a way to provide values that this action can use to run its calculation. And we call those values, when you're passing those in to a reusable set of logic, parameters. And parameters are like variables, only when you're within the logic of an action, they have a few extra fields. So we get this parameter name field, and then we get a type, which will be one of the primitive types, a default value, and then we can use the test value field in the same way that we use it for attributes. If we think about what we're doing here, clamp, we're going to need 3 parameters. One, the value that we want to clamp, and then one for the minimum, and then one for the maximum value. So I'm just going to duplicate this 2 times. And then we'll label them minimum, maximum, and input. Zoom out a little bit. And then we're going to return one of 3 things. I'm going to duplicate this twice as well. So remember that the return node ejects the value that it's given outside of this logic. In the case of primitive attributes, that means it's going to assign it as the derived value. But in the case of actions, it means it's going to return it to the logic that is calling this action. And And I'll show you how that works after we set this up. We know that the value that we ultimately want to set, the result of this calculation, will be assigned to one of these return nodes. If the input is less than the minimum, we want to return the minimum. Right, so I'm going to bring out a less than, and we'll attach this to say input is less than minimum, and then we will attach that to the execute input of this top return node. So this return will only be active if the input is less than the minimum, and if that's the case, we want to return the minimum. Let's set a minimum of 1 and an input of 0. That makes this true, and then this return node is activated with the value of 1. If the input is greater than the maximum, we'll attach that to the second return node's execute, and then we'll return the maximum. Now notice that, let's change this up to, say, a maximum of 2, and then we'll set this to be 3. So this is now true, and then we're returning 2, which is the maximum value. But if neither of these are true, then we want to just simply return the input value, which will be just 3. I said before, when we talked about ordering nodes, and the very first return node that is being executed will be returned. So this is active, right, because our input is greater than our maximum. So this return node is going to be what is ultimately, providing the final result of this calculation. Even though this return node has a value of 3, because it's lower than this middle one, it's going to be ignored. If this were up here, then you see up here the derived value becomes 3, so the return value of this action is 3. So we want to make sure that this is the lowest one, which is why I put input down here at the bottom. You could also set this up with conditions to make sure that only one of these return nodes is active at a time, and that would work just as well, and then you wouldn't have to worry about the placement of the nodes. This is just a bit simpler, so I'm going to do it this way. We raise this maximum up to 5, and then we can change this, and the derived value will be whatever the input is until it reaches that maximum. So this works within the logic of this action, but this will never be executed, because remember, actions have to be triggered manually. And even if we were to assign this to some button on the character sheet, it wouldn't do anything because we're not providing any of these parameters. And then we don't have any side effects in here, so nothing would happen. But what we can do is use this within some other attribute to just reuse that logic. I'm going to open up strength. And instead of just setting the minimum and maximum to strength, I'm going to use this as an example. And I want to use this clamp action. So notice we have these 3 inputs, and we get 1 for each parameter that we made in the action. We can wire up numbers to these parameters, and then the value of this action node will become the result of the action logic. Start with just getting some numbers out. Let's set a minimum of 0 and a maximum of 5, and then we'll control it with this input. So if we're between 0 and 5, we'll take the value of the input. If we go above that, we get clamped between up to the maximum, below clamped to the minimum. You can use actions like this to capture basically anything that QuestBound can do within its logic. So you can encapsulate that, and then you can reuse it in all sorts of different attributes. I'm going to move on now and show you some examples. I'm just going to make a few simple RPG systems, and I'm going to try and use as many of the different topics we've talked about, and cover a few different use cases that you might find useful. Okay, so first thing I'm going to do is make a simple health system from scratch. We're going to have hit points, actions to damage and recover those hit points, and then I'm going to have statuses for a weakness and a resistance. I'm going to make all of those attributes up front, say hit points, which is a number. We'll have damage, which is an action. Recover, also an action. And then we'll have, we'll just say weak, be a Boolean. And then resistance, also a Boolean. I'm going to set up a section in the sheet template to just go ahead and do this. So hit points will be controlled. It's still up to the player to decide how many hit points they have or to manage that. I'm going to bring out a character portrait just to make a simple sheet setup here, something like you might actually have. Take this. And then let's have some indicators. We'll control if a character is weak or if they're resistant. And then we need these actions. So down here, I'm going to bring out text. I'm going to make this one, just going to find an appropriate emoji. 1 second. That looks good. This will be the attack, and then we'll have another one for recover. It's going to be a little hospital. Okay, so assign the action of damage and then of recover. We'll make hit points a little bit more attractive, just a little bit, by giving it a border, a width of 2. Okay, so here's our simple character sheet. I'm going to add a couple of labels. Which one was this? I already forgot. Weak and resistance. So what I want is first to wire up attack and recover just to reduce and increase hit points. So I'm going to, let's go back into attributes. Hit points I'm just going to default to 100, make that a little easier, and then go into damage. So damage is an action. It will only ever be manually triggered, and since we intend to use it to alter other attributes, we need side effects. In this case, hit points. Oh, that's the attribute. We want a side effect. We need this as well. And we want to subtract it by the number 10. Wire that up to subtract, which will give us a value here that we can attach to the side effect of hit points. Now back into our sheet. If we click this, this damage icon, it's going to lower our hit points by 10 each time. And then our player can still raise it. Then every time we click damage, it'll lower it by 10. Next up, we need to recover by 10. And we'll do that in the recover attribute. It's going to be so similar to damage. I'm actually going to copy that and then paste it into the recover attribute. And then You have to click twice to confirm, and then we'll open that up, and there it is. But instead of subtract, we're just going to change this to add. And that should be it. Back to our sheet. Reduce this to 70, raise it back up 10 at a time to 100. Now what we want to do is say that if a character is weak, they will receive even more damage per the damage action. We're going to go back into the damage logic, and then we want to change this number to be, let's say, 20 if they're weak, or 10 if they're not weak. I'm just going to bring out a condition and the weak attribute. I'm going to wire that up there. And then we'll disconnect this number. And we'll say we're essentially going to set the appropriate number depending on the condition. So if true, then it will be 10. And then if false, it will be 20. And then each of those sets can get added to this subtract. Oops, that says 1020. Added to this subtract node. Oh, that's the opposite of what we want, isn't it? If true, 20. If not, 10. So when a character is not weak, we're going to reduce their HP by 10. When they're weak, we're going to reduce it by 20. Okay, back to our sheet template. Bring this down to 90, then 80, and then we'll recover that back to 100. If we're weak, a single click brings it down to 80, then 60, and so on. We still recover 10 at a time. What about resistant? If they're resistant, we should reduce it less than 10, say maybe 5. Okay, so if you are resistant, let's say that that just reduces the damage that you take by 5 in any case. So if you're not weak, you're normally receiving 10 damage. If you're resistant, you receive 5 damage. If you are weak, you're receiving 20 damage. Resistance will bring that down to 15. So what I want is an easy way to see the amount of damage we're receiving. I'm going to disconnect these sets from this subtract. This subtract node is what we're feeding the damage amount into. So down here I'm going to add an add node and give both of these sets, input those into add. And this add essentially becomes the damage amount. It's 10 if you are not weak, it's 20 if you are weak. So I want to reduce this by 5 if the character is resistant. I'm going to bring out another if node, and we're going to need resistant. Feed that into the condition, and then one more set to say if this is true, execute this set, and then that's going to provide the number -5 because we're adding it into this damage amount. We're up here, this is ultimately the amount of damage. If you are not weak, not resistant, it's 10. If you are not weak, you are resistant, it's 5. If you are weak and not resistant, it's 20. Weak and resistant, it's 15. That seems right. So now we just need to feed this into subtract, and we get the final result. Let's test it out. Not weak, not resistant, we damage 10 at a time. Weak, not resistant, we damage 20 at a time. Not weak, resistant, that goes down 5 at a time. And then finally, weak and resistant, 15. That works. There's our very basic health system. We can extend this to have different types of weaknesses and resistances, different types of damage, all sorts of things. And next up, I want to make a system that incorporates some random chance. All right, so I think let's do a couple of status-like attributes. Let's say blessed, which is a Boolean, and then cursed, also a Boolean. And then I want an action that says, let's just say take chance. This is an action, and it's basically gonna maybe do like a 50-50 chance. Either you're gonna get blessed or you're gonna get cursed. So within the, I think let's go ahead and make a little area for this in our sheet. And I'm just gonna make a new page. Call this chance. And then we'll do a couple of text components. This will just say blessed. And then we'll get one that says cursed. And maybe we'll make this red just to make it real obvious. Oranges. And so cursed is only going to appear if cursed is true. Blessed will only appear if blessed is true. And then we need a button of some kind. We're just going to use this shape. We'll assign that to our take chance action. So there's nothing really rendering here except for our button. We need to go into the logic of take chance. And we need some way to do a 50-50 here. We can do that with a dice node. And the dice node just rolls some number of some-sided die. We can attach a text primitive up into this, this number input. And then this expects this is like the common format, like 1d6, where 1 is the number of dice and 6 is the number of sides. And we're looking for a 50-50, so we can just roll 1d6. This doesn't have to be a realistic like polyhedron number. This could be a 7-sided die, it could be a 1-sided, right? But for the sake of making this more like a tabletop game and a mechanic that you can reproduce in real life, we're going to leave it as 1d6. This gave us the number 6. That's because we happen to roll a 6. Every time you change this, say to a 2, it's going to re-roll and it will leave that number there. But know that every time this action is run, the dice will be re-rolled. So you're going to get a new number every time, which makes this what you'd call a non-deterministic action. And you can't predict what the result of this is going to be, which is exactly what we want. So here is a number. This dice node essentially becomes a number primitive. We want to bring out a branch. And our condition will be if this is greater than the number 3. This should give us a 50-50 chance that this is true or false. And we're going to use that and feed that into our condition here. It's true right now because we rolled a 6. If we rolled, actually this is not a 50-50, is it? We need less than or equal to. Yeah, less than or greater than equal to, doesn't matter. So a 1, 2, or 3 will give us a true result. A 4, 5, or 6 will give us a false result. I'm going to flip this to greater than or equal just because it's easier for me to read it that way. But it's the same exact thing. So what do we have here? We want side effects, right? Side effects of either cursed or blessed. I just brought out these attributes. We need side effects. We'll duplicate this. Side effect of blessed, side effect of cursed. And we'll drag out the active branches here into the execute inputs of these side effects. So only when this condition is met will we execute the blessed side effect. And when it's not met, we will go cursed. And then we just need a single Boolean, true, to provide the value of both of these. Roll 1d6, 1, 2, or 3, set the cursed to true, 4, 5, or 6, set blessed to true. Let's go into our sheet template to the chance tab. All right, so now if we click our button, we got cursed. Open up this event log. We rolled a 1, so we got cursed. Cursed got updated to true as a side effect of take chance. I'm going to click this again, and we got blessed. Rolled a 6. Look at that, a 1 and a 6. And so we can keep doing this. Of course, we're already blessed and cursed, so it's not going to change anything. It might be nice if we removed both of these statuses every time we took a chance. So back into the logic of take chance. What we can do is duplicate each of these side effects. And then we'll flip them up here. What do we want to do? We want to say no matter what. Well, no, this is right. So if we roll a 4 or higher, we will flip blessed to true and cursed to false. And then the opposite down here. Let's see if that works. So only one of these should be active at any given time. We're cursed, and then we're blessed. We see that we rolled a 3, blessed got updated to true, cursed got updated to false. If we click this again until we get cursed, then we get it flipped. All right, the last example I'm going to do is recreate the D&D skill system, which, if you're not familiar, you have 6 core attributes that each have a derived modifier. And then that modifier is used to add to a skill if you have a proficiency in that skill. And then there's also the modifier is used to just derive the skill bonus, and then you have a proficiency bonus based on some other attribute. So we'll create some of this. Let's do it just for, let's say, dexterity. So you have a dexterity score, and then a dexterity modifier. And then you have like an acrobatics, which I think uses dexterity. Acrobatics score. You have an acrobatics proficiency, and then you have a proficiency bonus, which is true or false. And then remember we made a chart earlier which just takes the score and then it supplies the modifier. We'll use that. And then we will get all this stuff wired up. Let's start with our sheet. I'm going to make a new page called skills, not with a Z, skills with an S. And then we will drag out an input for dexterity, a text that says dexterity modifier, We'll have a proficiency bonus. Where's this? Oh, we didn't make proficiency bonus. We made it a Boolean. That's not right. It should be a number. Proficiency bonus, and then we'll have athletics. Do we say athletics or acrobatics? Acrobatics. And then what we need is acrobatics proficiency, which we also didn't make. Lots of attributes. That's a Boolean. Bring that up right here. So from this, we should be able to change our dexterity score, derive our dexterity modifier, apply that to our acrobatics score, add a proficiency bonus to change this default value that will be applied to acrobatics when this checkbox is true. Let's change this before I forget. Proficiency bonus 5. This will be a static number. This is also derived from some table in D&D, but we're not going to do that part. Okay. So first step, let's derive the dexterity modifier from dexterity score. Do that in modifier. What I'm actually going to do as an example is make an action to get the modifier from that table, and then we'll be able to reuse that action in all core attributes from D&D. If we're going to make all 6, we don't want to redo the chart lookup 6 times. We want to just do it once. So we'll make an action called get modifier, and we'll start with that. Get modifier, we'll take a parameter that is the score, and we'll take another, no, it'll just take score. That's a number. Then we have the modifiers chart. Select from modifier where score is equal to the parameter score, and then return that value. Test value of 10. Yep, it's just going to pull that. So all this is doing is this chart lookup. But now we can go into our dexterity mod, and instead of doing the chart lookup here, we're just going to use the get modifier action, and the score parameter will be the character's dexterity, and we will return that to set its derived value. So now as this changes, we get a modifier that gets set to dexterity modifier. So when we go to do the other 5 attributes of the game, we can just copy paste this very simple logic and not even worry about the chart. Skills, dexterity, score, dexterity mod changes right along with it. So next up, we want to derive the acrobatics score from our dexterity modifier. So this number, if I'm remembering correctly, the acrobatics modifier will just be the corresponding ability modifier. So it should just be 2 right now. And then if you are proficient, it will add your proficiency bonus. So let's go into acrobatics, the score. And this will just be dexterity modifier. Without considering the bonus, it would just be this. Yeah. let's test that before we move on. We change dexterity score, we get, yeah, acrobatics ultimately. Now if we are proficient in acrobatics, that will change our score. Oops, this is in, I made acrobatics proficiency twice. So acrobatics, I'm going to delete this one. This should be a Boolean. Yeah, so acrobatics. Let's bring out our acrobatics proficiency and our proficiency bonus. We want to say if we are proficient, we want to add, so I'm going to disconnect this. I'm just going to wire this directly to an add. And then we'll bring out a set that will only execute on a true condition. And we'll wire that up like this. We're not proficient. We're just going to directly take the dexterity modifier. We have a proficiency bonus of 5, let's say. If we are proficient, it will add that to our mod. Looks right to me. Back to our sheet. Dexterity score of 14, but we're proficient in acrobatics. Oh, that did not work. Proficient in acrobatics. Because I did not wire up the acrobatics proficiency to the component. There we go. Now it's adding 5. So I do want to show just one more thing, and it's a node that we haven't talked about yet. I'm going to make a new attribute called level. And let's pretend that level is derived from some other attribute like experience points. For now, I'm just going to leave it as controlled, but I want to announce to the player every time their level changes. So to do that, I'm going to go into the logic of level, and I'm going to use this announce node. And because this is in the logic of level, this announce will run every time the level changes. And we can attach some text to it and just say, like, you leveled up. Attach that to the input of announce. The icon here turned orange just because it has a connection. So now if I go back to my sheet, we'll do this in the skills tab, and I bring out a level input, and I change this to 1, I get a notification down here that says you leveled up. That'll last for a few seconds and then go away. And then every time it changes, it'll come back. All right, so you can make in-app notifications for your players this way and alert them to several different things. This is useful when you have sort of like nested embedded logic. And the event log is great for seeing like what's going on at a high level, but if you want to alert somebody in game of something that just happened, like they have a status effect or something important has changed, then you can use announce. So that's the last thing we're going to go over. This was a very long and dense video, so thanks for watching. We didn't quite cover all the different types of nodes and everything you can do in the logic editor. But if you understood everything in this video, you're going to cover like 90% of use cases when you're making your rule sets. For everything else, jump into our Discord server. We have a channel called Workshop, which is specifically for asking questions and figuring out what you can do within logic. Otherwise, I'm going to make more tutorials in the future that are more fragmented and focused, and we'll be able to go a little more in depth about everything you can do.